Hey, so what we want to be able to talk about today is theoretical probability. So we've done experimental probability where we talk about the results of an experiment and the probability that that gets us. So the probability of success was the number of successful experiments over the number of total experiments. So that was an actual trial and error type thing. Today what we want to talk about is we want to talk about theoretical probability. So in theory, if I shuffle these 52 cards, right? So there's 52 cards here, okay? If I shuffle them, what's the probability that I pull out a jack, right? Or what's the probability that I pull out a queen, okay? So that's what I want to talk about today, all right? So let's start by looking at some terminology again, all right? So the probability of success in theoretical probability is the number of successful possible outcomes over the number of total possible outcomes, okay? So in experimental probability, we were talking about things that have happened in our experiment. In theoretical probability, we're talking about the number of things that could possibly happen, all right? So let's do an example. So the probability of me getting a jack out of a deck of cards. So in a deck, there are 52 cards. So the total possible outcomes are 52. And how many of them are jacks? Well, 4 are. So 4 out of 52. That's our theoretical probability of getting a jack, right? And I can reduce these by dividing both the top and the bottom by 4, and we get 1 out of 13. That's the theoretical probability of getting a jack. What about the probability of getting a card that's a heart? Okay, well again, the total number of hearts that there are, or the total number of cards are 52, right? And the number of cards that are hearts are, there's the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So 13 hearts. So that's 13 hearts out of 52. And I can reduce these by dividing both of them by 13, and we get 1 out of 4. So I have a 1 out of 4 chance of pulling a heart, okay? Now, what about a jack or a queen? Okay, well, the total number of successful outcomes in this case are jacks or queens. So that means, again, 52 total cards, but jacks or queens are successful. That means 4 jacks and 4 queens, so 4 plus 4. Okay, so that gives us 8 out of 52, right? Which is in this case 2 out of 13. Okay, so always we're doing the number of possible successful outcomes divided by the total number of outcomes that can possibly happen. So 4 jacks out of 52 cards, 13 hearts out of 52 cards, 8 cards are a jack or a queen out of 52 cards. Now, how about the probability of me pulling out a card that's black and a heart, so a black heart, okay? So in total, there's 52 cards. A card that's a black heart, well, how many black hearts are there? There's a bunch of red hearts, there's black spades, black clubs, but there are no black hearts. So that means it's 0 out of 52, okay? So the probability of getting a black heart is 0 out of 52, all right? So let's look at one more example. So if I have 4 shirts, blue, red, green, and yellow, and 3 ties, blue, red, and green, to choose from, what's the probability that I'll wear a blue shirt with a red tie that day? Okay, so this case is a little bit more complicated because I have 2 things happening. I'm picking a shirt and then I'm picking a tie. Okay, so here, I was always just picking one thing, right? A card. Okay. Here, I'm picking 2 things. So if we need to keep track of 2 things, a really helpful strategy that we can use is called a tree diagram. Okay, so the tree diagram has my first action broken into branches. So 2, 3, 4, because I have 4 shirts. So this would be a blue shirt, a red shirt, a green shirt, and a yellow shirt. Okay, so 4 shirts to choose from. Okay, once I choose my shirt, then I have to choose my tie. Okay, so that means after I choose a blue shirt, I could choose blue, a red, or a green tie. Blue, red, green. Okay, if I chose a red shirt, I could choose a blue, a red or a green tie. Okay. After I choose a green shirt, I could choose a blue, a red, or a green tie. And after I choose a yellow shirt, I could choose a blue, a red, or a green tie. Right? So see how my first is my first choice. So that's shirts. And then I choose my ties. Okay? So shirts and then ties. So one branch and then another branch. Now, we just want to count the number of successful outcomes, right? So we want the probability that I'll wear a blue shirt and a red tie. So that's blue shirt and then a red tie, right? So that's one successful outcome, okay? How many total outcomes are there? Well, I could wear blue and blue, blue and red, blue and green. That's 3. Red, blue, red, 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 green. That's another 3. Green, blue, green, red, green, green. That's another 3. And then another 3 here. So my total number of outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my total number of outcomes is 12, right? And my number of successful outcomes is just blue and then blue, red, right? I want a blue shirt and a red tie. So blue, red, that's one outcome out of a total of 12. So this is the probability that I wear a blue shirt with a red tie that day. Okay? All right, so that's it for theoretical probability. Remember, theoretical probability is what could happen. Experimental probability is what has happened. Okay? All right, that's that.